Hi guys, this is Mehul Mehta and welcome back to my YouTube channel. In this video, I'll give you the practical implementation of how we can use binomial tree method for pricing European call and put option. Also, if you have not seen the theoretical video in which I have told the methodology for it, I highly recommend you all to watch it. So let's understand how can we use binomial tree method for pricing European call and European put option. See, the first thing is uh, setting up the parameters, right? Is what I also told in the theoretical video. See, see the parameters will remain the same. If you see, stock price is 549, strike price is 555. Um, the current date you know of the option current date is 2nd July 2024, and the option is expiring on 9th of July 2024. So the maturity of this option contract is nothing but you basically subtract these two dates and divide it by 365. Then your risk-free rate is nothing but I have considered 5.5 as my risk-free rate. So if you have seen my Black-Scholes video, I've also told how to calculate the volatility, which is very simple. Take into consideration last 1 year of data. So since we are valuing SPY option contracts, so what I've taken is last 1 year. If you see the SPY historical data, so what I've taken is last 1 year, historical value of SPY. So if you see, I've just taken the adjusted close price of the SPY, and what I've done is I've calculated the returns of it. So how to calculate returns is current price divided by yesterday's price minus one. So this is how you calculate the basically the price of you basically calculate the return, and you just need to drag down the formula till the end. Also, I just want to also if you see here, I've just taken, if you see the counts here, I've just taken 252, which basically means this is last 1 year data. Also, if you might be thinking in 1 year you have 365 data, right? 365 days. But if you remove Saturday, Sundays, and your national holidays, the number of days that are left are 252. That's why. So if you see, I've taken 252 data points, which is nothing but your one year data. So the way I've calculated the volatility is, first use this function standard deviation dot sample, and in the sample what you need to give is the returns of the SPY, and then you just press enter. So this will give you daily standard deviation, but we need to calculate the annualized standard deviation. So to calculate the annualized standard deviation, you need to multiply the daily standard deviation with the square root of 252, and this is how you calculate the annualized volatility. So if you see 11.10% is what I have also used in the binomial tree method. So so this is how we can calculate the volatility by taking into consideration the historical value of SPY, and then calculating the daily volatility, and after calculating the daily volatility, multiply it with the square root of 252 to get annualized volatility. See, if you see between 2nd July and 9th July, right? If you see, we have 7 days of data. There's a difference of seven, right? And we have Saturday, Sundays coming up. So if you remove these two, you will have just five data points to consider. That's why if you see, what we have taken is five time steps. So, so I have just taken five time steps, which is nothing but it represents five trading days. Again, as I told you, we do calculate delta t, which is nothing but delta t. If you see, is nothing but the length of each time step, right? So how will we calculate delta t is t by n. So if you have not seen my theoretical video on binomial tree, I highly recommend you to watch that, so that it's easy for you to follow why we are doing this. So the first step we do is we calculate the delta t, which is t by n. So we already know. So if you see, we already know our maturity, which is t, and we also know our time steps, that is n. So we'll do t divided by n to get our delta t. So maturity is nothing but your t. So this gives you the number of, sorry, this gives you the delta t, right? So once you calculate the delta t, the second step that you need to do is need to calculate your up and down factor. So the up and down factor are just used to multiply your stock price. See, always remember, so this is one node, right? In your binomial tree. So, uh, so what you need at each node, your stock price can either go up or it can either go down. So this is the up movement of the stock and this is the down movement of the stock. See, this white, all these whites are the stock prices and this green are the option prices. So so initially what we do is first we construct the stock prices. Just remove, just don't think, as of now, don't think we have this, just think we have this. So how will we, so what you need to do is at each node you basically multiply the stock price with the upward movement and the downward movement, or you can say as up factor or the down factor, to get the price, right? So but the question is how to calculate the up and down factor. Is you can use this formula: u is equal to e sigma square root of delta t, and d is nothing but 1 by u, which is nothing but e minus sigma raised to the square root of delta t. So we'll just use the same formula for u and d, which is e sigma we have already calculated, which is our annualized volatility. This multiplied by square root of delta t. So this will give you our up movement or up factor, and d is nothing but 1 by u, or which is nothing but your down factor. So once you have your up and down factor, what you will do is you will multiply the stock price with the up factor, and here, so if you see, you're multiplying s naught with u to get the stock price at t equal to 1, and to get the down price, you are multiplying s naught by d. So this is how you will just construct the t, that is multiplying s naught by u, s naught by u, s naught by u. So always remember, at each node it will go into two direction, right? This is the assumption of your binomial tree method, that at each node it can just follow two direction. The stock price can just go up and it can go down. So first it will go up and then it will go down. Similarly, at this node it will go up and then it will go down. Similarly, at this node it will go up and again it will go down. So we'll construct this tree, we'll construct this tree. So at this node it will go up, it will go down. At this node it will go up, it will go down. Similarly, at this node it will go up, down. And similarly, you'll just build the tree, which is up and down movement of the stock price, right? So this is how at t is equal to 5, this is how at t equal to 5 the prices of your stock will look like, your up and down movement, right? So once you do this, once you construct your tree, the next step is, so once you calculate the up and down movement, and then the next step is calculating the risk neutral probability. See, the risk neutral probability is nothing but what is the probability of the upward movement and the downward movement. See, u and d basically tells you how much can your stock go up and how much can your stock go down, right? Where P and 1 minus P tells you what is the probability of going up and what is the probability of going down. Also, P and 1 minus P are nothing but they are considered as risk neutral probabilities for upward movement. So, probability of upward move and probability of downward move. So, we'll calculate P and 1 minus P, which is nothing but if you see the formula, E of R delta T minus D divided by U minus D. So what we will do is P is equal to exponential of R delta R, this is risk-free rate, times delta T, which is B9 minus D, right? And then divided by U minus D. So this is the formula that you will use to calculate the P, and 1 minus P is nothing but you just subtract 1 from P. That's it. So this is how you will calculate P, which is E R delta T minus D U divided by U minus D. And this is how you calculate 1 minus P. See, the best thing you can do is, just follow the steps. Calculate delta T, calculate up and down factor, then calculate risk neutral probability of upward movement, downward movement, and then you can construct the binomial tree. So I told you how to construct it already. At each node it will go up and down, right? Up and down. So similarly, you'll at this at t equal to 5, you just need to follow this up and down movement. So next step, once you have this, basically once you have this, sorry, oh, this was the call option, right? What we were doing. So once you have this, what is the next step? Right? What is the next step? The next step, if you see, next step is nothing but to calculate the option payoff at expiry. So how will you calculate the option payoff? Nothing but if you see the formula for option payoff is for a call option, it is maximum of st minus k comma 0. And for a put option, it is nothing but maximum of k minus st comma 0. So at this particular node, what we will do is, of this particular node, what we'll do is we already have the stock price, right? We already have the stock price here. So we'll just at this t equal to 5, we'll just put maximum of st minus k. So k is your st and k is nothing but your strike price, which is here, right? So you'll just do maximum of st minus k comma 0, and you'll just put this the same formula everywhere, not everywhere, but basically at t equal to 5. So maximum of st, which is nothing but your stock price, minus k. Similarly, maximum of st minus k comma 0, maximum of st minus k comma 0. So always remember, you will use the formula only at the final node, or you can say only at the maturity. So always remember, this is how it is. I mean, this is how the formula will flow. Just use the option price formula to calculate the option price at the maturity. So once you do, what is the next step? The next step, if you see, is back propagation. So what you need to do is, and if you have not seen my theoretical video, I highly recommend it to watch, because I have explained in detail like how we are basically following all the steps. So what we are doing is, whatever call option price we are getting at up node and down node, so we are multiplying p with the up node and 1 minus p with the down node. And once we whatever value we get, we discount it with by multiplying it with e raised to the power minus r delta t. So what we are essentially doing is, we have used the option payoff formula at the final node. Now how to get now what we'll do is we'll back propagate. So what do I mean by back propagate is, we'll calculate the option payoff at t is equal to 4, then we'll calculate the option payoff at t equal to 3, t equal to 2, t equal to 1, and finally we'll calculate the option payoff at t equal to 0. And whatever value we get at t equal to 0 will be a final call option price. So let's see how to get it. So what we are essentially doing is, we are multiplying p with the up value, and then if you see d, if you see, this is nothing but our p. We are multiplying it with the up value, which is k7, which is this value, right? And then we are multiplying d, which is nothing but your, if you see, 1 minus p is your 1 minus p is your k b13. We'll multiply it with the down price, we have down stock price, which is k9. And then you just need to multiply with xr minus delta t. So r in this case is 5.5%, and delta t is what we calculated. So you just need to multiply this to get this price of you to get this price. Similarly, how will we get this price is nothing but just multiply this with p, multiply this with 1 minus p, and then just multiply the whole with e raised to the power minus r delta t. So if you see this price, what we are doing is, we are multiplying p with k9, right? Then multiplying 1 minus p with k11. So this is k9. This is yeah, sorry. So yeah, this is k9, which is this sorry, yeah, the option price here, and then we are multiplying 1 minus p with the option price here. So so once you multiply it, and then you multiply the whole with exponential of r delta t. So okay, so I guess I just did one small mistake here. So I guess I have not yeah, I have not used minus. Let me implement minus. Yeah, no worries. So what we can do is, we just can copy paste the whole formula again. That's it. Yeah. Now, yeah. So we have discounted it properly. Yep. So now what we are gonna do is, if you see, we are multiplying this with p, this with 1 minus p, and then you multiply the whole value with e raised to the power minus r delta t. Similarly, to find this value, you multiply this with p, this with 1 minus p, and the whole multiplied by e raised to the power minus r delta t. So this is how you will find the value at t equal to 4. Now to find the value of at t equal to 3, right? What you will do is you multiply this with p. As we see this formula, we are multiplying this, the b12, which is p, with j8, which is this value, and then we are multiplying b13, which is 1 minus p, with j10, which is this value, right? So, and then basically what we are doing is exponential of minus r delta t. So once you do, you'll get the price here. Similarly, you just use the same formula. P times the up stock price, 1 minus P, 1 minus P times the down, sorry. Okay, let me repeat. So P times the up option price, 1 minus P times the down option price, and then the whole thing multiplied by E minus R delta T. Similarly, how will you find the value here? P times the up option price, D times the down option price, add it, and then multiply the whole with e raised to the power minus r delta t. So this is how you will calculate at t equal to 3. Similarly, you'll just back propagate the same formula, the same formula here. So if you see, let's see here. So what you're gonna do is you multiply this value with p, then multiply this value with 1 minus p, add them, and then multiply everything by exp raised to the power minus r delta t, and similarly same formula for this. And then at t is equal to 0, this is what you will do eventually. Multiply this with P, the down option price with D, and sorry, up price with 1 P, down price with 1 minus P, add them and discount it. So whatever price you're getting at here, this is your final call option price. So this is your final call option price, which is nothing but this value. Okay. And similarly, now let's see how can we do for a European put option. But up till now, do you have any doubts, guys? Up till now. Okay. So I'll take that as no. So now how to do put option, right? Similarly, see, only in put option, you'll first construct the tree using the stock prices, right? Similarly, you'll complete the whole, you'll build this whole tree. And then eventually in the end, you just need to change the payoff formula. So for a put option, what is the payoff formula? It is K minus ST, maximum of K minus ST comma 0, right? So if you see here, what is the formula? Maximum of, if you see here, K minus ST. So if you see, B2 is nothing but your K, and minus ST is nothing but your stock price as at this node, comma 0. So you'll just use the same formula, maximum of K minus ST comma 0, to calculate the price at each node. Okay. And then what you need to do is you just need to discount it. Again, I'll just include minus here, so that yeah, it is the right way. Yep. Okay. So now what we are eventually doing is, we need to uh, always remember, we will use the payoff formula only at the final node. But to find the option price at the previous node, you just need to follow backward propagation, right? So for backward propagation, what you will do is similar thing. P, P times this value, 1 minus P times this value, and then whole multiplied by e raised to the power minus r delta t. So if you see here, B12, which is nothing but your P. So B12 is your P times the stock price at the up node. Again, K13 is your 1 minus P times D, which is the stock price at the down node, and this whole multiplied by R delta T. So this is how you will find the price at previous nodes, and using this formula, using the same formula, you'll find at each node. Okay, you'll find the value at each node. So finally, when you arrive here, right, you just need to go, first you will go at t equal to 4, you will find using the backward propagation, find the values at t4, find the values at T3, T2, T1, and then finally, how will you find the price? Similarly, multiply the option price with P, up price with P, down price with 1 minus P, add them, and then multiply everything but exp raised to the power minus R delta T. So this is nothing but your put option price, right? So if you see, your put option price is nothing but this, which is 6.80. So this is the price that you got. Now, if you see the Black-Scholes model, right? So in from the Black-Scholes model, what price you were getting for the call contract is 1.344, and what we are getting is 1.39, right? And similarly, from the Black-Scholes model, right, put value what we were getting was 6.758, and from the binomial tree what we are getting is 6.8. So very close again, but yeah, it's different, but yeah, close. And see, one more thing, if you have not seen my theoretical video on binomial tree, I highly recommend you guys to watch it, because in that only I have told you how we are calculating, constructing this binomial this tree, and then how we are calculating the price at this. But eventually we are just following the steps which I just showed you, and the final price of the call and put option is nothing but the price that you get at the zero node. So if you see at the zeroth node, whatever price you have for call and put will be your final price. So any doubt up till now? Yeah, please feel free to ask any doubt, even if it's the smallest of the doubts.
Meola, I have a question.
Yeah.
So it's like it's an Excel question.
Yeah.
So now you calculated each node, right?
Right.
So you
Right.
put a different formula at each node.
Mm-hmm.
But there is a possibility that like the value of t can be like 20 or 30 also, right?
Right. So.
So
Mhm.
like if we calculate in Excel, it can get complicated, right?
Yes, I agree, and
Because if
that's why if you see all the asset pricing, I mean, what people are using is Python and C++, because in Excel, I mean, see, to be honest, I mean, what if you have a 1 year contract? I mean, right? So this T will go to till 252, and doing this in Excel, it is so challenging because uh, I mean, it's very frustrating. I mean, very time consuming. Also, you can make small errors like what you saw, right? I instead of discounting it with minus R delta T, I just discounted it with R delta T.
right.
So that's why people are using Python, and so a lot of people use Python to build all this code because it's much more easier in Python, and it's also time efficient.
Okay, got
Yeah.
it.
Yeah.
That's all, Mehul, from my side.
Okay. Any other doubts you all have? Okay. So thank you so much for joining the session. I'll just stop the recording.